Hello students, welcome to your video on systems of equations. Just played a little bit of Linus and Lucy there in the background, and I'll turn that back on in just a minute. But thought I would give you a chance to read the comic that I stuck up there on the front screen. Let's jump right in and talk about what systems of equations are. Okay, a system of equations is a set of two or more linear equations. The number of equations in a system is the same as the number of different variables in the system. We're going to stick to two variable systems. Those would be ones that contain the variables x and y. So just two variables, x and y. Alright, any ordered pair like this that makes all of the equations in a system true is a solution of the system of linear equations. So basically what we're going to have here is two lines on one coordinate plane. Well, when you have that, you have three different possibilities. And these are the three possibilities. Most of the time, your two lines are going to cross. They're going to intersect. There's going to be an intersection point. And those lines intersect at a single point, one point. The lines that we're talking about here have different slopes. And when we talk about this system, we say that this system is both consistent and independent. And it's consistent because it has a solution. It's independent because that solution is a single ordered pair. The solution to this particular system right here would be the ordered pair -1, 1. Okay, that's one possibility, and again, that's the most common one right there. Second possibility is that you have two different equations, but the lines are actually the same. How is that possible? Well, you may not recognize it in the equations. You've seen that we can write the same equation different ways, several different ways. So you can see how maybe you might have two equations but not see that it's actually the same line. In this case, both of the lines, both of the equations end up with the same slope and y-intercept. And this system is consistent. Okay, equations like this are consistent because there's at least one solution, but they're also what we call dependent. When we say infinitely many solutions, what we mean is that every single ordered pair all the way down this purple line, and it's purple because it's trying to indicate that you've got the red on top of the blue. What they're saying is every single ordered pair on this line is a solution to the system. So every point works in both equations. The third possibility when you have a system of equations is that you have two separate lines, but the lines are parallel. These two lines parallel right here. The lines have the same slope, but different y-intercepts. And the equations in this case are inconsistent, and that's because there is no solution at all. So to recap real quick, a consistent system has a solution. It could be one, which is most of the time, or it could be infinitely many if it's two equations the same line. A system that doesn't have a solution at all is inconsistent. A system that has a single solution is independent, while a system that has infinitely many solutions is dependent. We're going to try out some examples. So we're going to start with this first example, number 1. Two brothers are learning to manage their own money. Jeff has $20 and plans to save $2.50 each week. Gary plans to save $5 each week, but doesn't have any money saved up at the start. How long will it take before Jeff and Gary have saved the same amount? How much will they have at that point? Alright, so we're going to write a system of equations for this situation. So let's start off by defining our variables. We're going to have y represent the amount of money each boy has. We're going to have x represent the number of weeks as they pass. Well, Gary's situation is that he's going to make $5, save $5 a week. So Gary is going to save $5 per week. And we know that $5 per week, that's a rate. $5 per week, that's a rate of change, that's a slope. And if he doesn't have any money to begin with, we don't have a y-intercept, so we're not going to add anything to our 5x. The other person is Jeff, and Jeff starts off with $20. So there's a y-intercept on his. And what's the rate of change for Jeff? Well, Jeff is going to save $2.50 each week, so 2.5x. And so here we have a system of equations with the same variables, different slopes, so we know this is going to have a solution. So what we're going to do in order to figure this out is we're going to graph both of these lines on the same coordinate plane. And here we have it all set up to go ahead and graph. We have got our, let's see, we've got our number of weeks here on the X and our money saved on the Y. Let's go ahead and graph each one, and let's use the appropriate color that we wrote the equations in. So we're going to start with Gary. Yes, that's right, Gary. Gary was our red equation. He's got a y-intercept there of 0, because he's not saved any money to begin with, and a slope of 5. So be careful here. Remember that when we're doing an application of a real-world problem, we don't always have the same factor we're counting by on the x and the y-axis. So rise of 5, run of 1. It's going to put me here, and here, and here, and so on, all the way up the graph. So that's going to give us this shape. Oop, not perfect. Sorry about the wobbliness there, but that's pretty good. All right, now let's go ahead and graph Jeff's line. So he's got a y-intercept of 20 to begin with, and then a slope of 2.5. Well, I want to make this simple for myself. So 2.5 over 1, I can double those. I can make it 5 over 2. So a rise of 5 and a run of 2. So from here, rise of 5, run of 2 is going to take me all the way across to there. And so on. And there it is. You can see where they cross. Now I can't fit another point for Jeff's line on here, but I can see this important point right here. What is that ordered pair? That's the ordered pair 840, and it also answers our question. How long will it take for them to have the same amount of money? It will take in 8 weeks. And there you have it, that part in a sentence. And second of all, what will that amount be? Well, it will be $40. All right, so that's one system. That's a system that has a solution. Let's take a look at the other types of systems, continuing our story of Jeff and Gary. Okay, Jeff decides to rethink his plan, and he comes to the decision that he will also save $5 per week. So again, we're going to write and graph a system of equations that describes our new situation here. All right, so remember Gary was in red before, so Gary's situation isn't changing, so his equation stays the same. Jeff, on the other hand, Jeff's changing a little bit. Instead of, he's still going to start with $20, but instead of getting $2.50 a week, he's going to have $5 a week. So you can already probably tell what's going to happen here, but let's go ahead and graph it. And here we have it set up to graph again. So, Gary, again, y-intercept is 0 and a slope of 5. There we go. And Jeff, again, y-intercept of 20, but this time he also has a slope of 5. So, his line is going to go up at the same angle as Gary's. So what does that mean? What does that mean for their situation? When will they have the same amount of money? Well, Jeff and Gary will never save equal amounts. This system has no solution because those lines will be parallel. They'll be the same distance apart forever. And a big part of that is the fact that they have the same slope. So both of them have the same slope, 5, but they start at different y-intercepts. So it's an inconsistent system, and as a result, Jeff and Gary will never have an equal amount. All right, last one. Gary's mom and aunt decide to help him out by giving him $15 and $5 respectively toward his savings. Write and graph a system of equations to describe this third and final situation in the saga of Gary and Jeff. Okay, Gary. So what Gary had before was $5 per week. But now he's got $15 from Mom plus $5 from Auntie. And we'll come back to that because I know you already see what's going to happen here. Just bear with me. And then Jeff has $5 per week and his $20 that he started with. And I know you can already see what's going to happen with Gary, but let's go ahead and graph it anyway. And we're ready to graph. And obviously, it's the same equation now. So what we end up with is the same line. So when will Gary and Jeff have the same amount saved? Well, Jeff and Gary will always have the same amount. It's a dependent system. Every ordered pair is the same in both lines. So this is a circumstance where you have an infinitely many solutions, or infinitely many ordered pairs that are solutions to the system of equations. And that just about does it. Let's do a quick summary slide and we'll be done. Okay, 2 or more equations make up a system. Most of the time, the solution of a system is an ordered pair, the point where the lines cross. And it was kind of obvious because the other 2 examples in our situation were kind of silly. One where they're never going to have the same amount of money, one where they always do. More than likely, most circumstances, you'll have the 2 lines that actually cross. But if the 2 lines in a system are parallel, the system has no solution, and if the 2 equations actually form the same line, the system has infinitely many solutions. That was a pleasant video. I hope you enjoyed the Charlie Brown holiday Christmas soundtrack in the background. I'll make sure I put it in my YouTube description. Hopefully I do it right. Thanks, guys. I'll see you in class.